Now we're going to examine a velocity time graph. And in this graph, we will ask ourselves, is there a way to determine the displacement? Can we determine whether or not the object is accelerating? And can we determine the acceleration of the object at any moment? Here we have four velocity time graphs that we can look at. We can use this first one here just to kind of get the basics. First of all, you notice that your y-axis is velocity in meters per second, and your x-axis is time in seconds. Now, you notice I got the x-axis in the middle here, and that's for a reason. This line right here also is meant to represent zero velocity. So anywhere along that line, you're not moving. All right. Here, change color here. Anywhere up here is a positive velocity. So as long as you're up here, you're traveling in whatever's been designated the positive direction, forward, north, east, that kind of thing. And if you're down here, then you're traveling in the negative direction. So on any velocity time graph, you need to identify where is zero and where is positive and where is a negative velocity. Now this particular graph, you'll notice the velocity stayed the same the entire time. So we want to look at our three questions. Can we find the displacement from this graph? We absolutely can. We're going to find something called the area under the curve, and that's going to be this area under here. But this is such an important topic that I'm going to dedicate a separate video to that. So the answer is yes, you can find the displacement, but we're going to hold off on that for now. The second question is, can you identify, is this accelerated motion or not? Well, obviously this object never changed speed, so therefore obviously the answer is no, it is not accelerating. But also look at this line here. What is the slope of this line? Well, if it's rise over run, there's no rise, so it's zero over the run, so the slope of this line is zero. But what are the units of the slope? Just like we did with the position time graph. Well, the units would be meters per second over second. Well, that's meters per second squared. And so we left with a very, very important idea that slope on a velocity time graph is the acceleration. So you need to memorize that. That would be very useful in looking at graph problems. The slope on a velocity time graph is the acceleration. In this case, so I would look at this and I could say this object is moving forward at a constant velocity and not accelerating. All right, let's look at this graph. Here you notice that he starts on this line, the zero line, so he starts at rest. That's a term you'll see a lot in problems. He starts at rest right there. But here his velocity is certainly changing. And so we could find the acceleration, of course, by finding the slope of this. So if we had data points, we could plug in rise versus run, and we could get the actual value of the acceleration. But what I want to focus on here is you'll notice that this is a positive slope. And that means you have a positive acceleration. But it's also a positive velocity because it's up here. And we've learned that if you have positive acceleration and positive velocity, you are speeding up. So this is an object that's getting faster and faster in the positive direction. Let's come down here. And this is actually in several parts. In fact, it's useful sometimes to break these graphs into little pieces rather than try to look at the whole thing at once. Down here, he started at a high negative velocity. So he was going pretty fast in the negative direction. So he's got a negative velocity here, but you'll notice this whole line is positive. The slope of that line is positive. So he has a positive acceleration here. So from here to here, he's slowing down because his signs are opposite. What happens right here? Well, he's crossing the zero line. So at that moment, he's at rest. But it's just a moment. You notice he doesn't hang around on that line. He just passes through it. So it's a momentary stop. And we will look at some motions like if you throw a ball up into the air, at the very highest point, it does stop for a moment. That would be the kind of thing you'd see on this graph. Now, up here, he has a positive velocity, but he still has that positive acceleration, which means up here he is speeding up. Let me come back to something right here that is so confusing for students. At that moment right there, we know his v is 0. But what is a? Is a 0? No, a is, that point is still part of this line. A is still positive. Whatever that value is, it's still the same there. The big mistake students make, that because the object is stopped, it's not accelerating. According to this graph, it is still accelerating, even though for that moment it stopped. What might be this kind of, what is going on here? Well, it starts off going backwards very fast, slows to a halt, and then goes in the opposite direction with an increasing speed. So this is an example of an object that changed direction. Same thing's going on over here. We see positive velocity but negative acceleration. And down here we see negative velocity and negative acceleration. So here's an object that starts fast forward, slows to a halt, right there, 0, and then turns around and goes in the opposite direction at an increasing speed. This, we'll find out, is an example of you throwing a ball straight up into the air. At the very beginning, it's got a high positive velocity. Just as it leaves your hand, it reaches its highest point and stops, and then it turns around and comes back towards you, going faster and faster. There certainly is a lot of information that you can get out of a velocity time graph. We've covered most of it. I will cover the displacement part, again, as I said, in a second video.